the standard deviation is the root mean square of the deviations of the list from the mean of the list. So we need to define what root mean square RMS is in order to do that. And the difference that you're going to see if you've taken statistics before, you might have been taught that the standard deviation involves dividing by n minus 1. That's a different critter called the sample standard deviation. And we'll talk about that later. It's used to estimate certain things. Here we're talking about just summarizing a list of numbers. Standard deviation, what's going to be in the denominator is just n, not n minus 1. All right, so what is the root mean square? It's the square root of the mean of the squares. Okay, root of the mean of the squares. So if you have a list of numbers, the RMS of the list is how you get it. You square the numbers in the list. You take the squares. You take the mean of the squares. You divide that sum of squares. You add up all the squares. You divide by how many numbers there are in the list. And then you take the square root of that. So you've got the root of the mean of the squares. It is a measure of how large an element of a list typically is. You could have a list of numbers that has a mean of 0, right? If you add all the numbers up, you get 0. You add them all up, divide by n, you get 0. And nonetheless, none of the numbers is 0. The numbers could be quite big in magnitude. Some large positive numbers could balance some large negative numbers and cause the mean to be 0, right? So this is a way of removing the sign from the elements of the list so you get an overall summary of how large they are. It's not the only way of doing that. You could, for example, add the absolute values or average the absolute values of the numbers in the list. Or you could average the fourth powers of the numbers in the list, or whatever you want, something to just sort of get rid of the sign so that negative numbers and positive numbers don't cancel each other. This is one way of doing it. It's the root mean square. Okay, so just a quick example. If we had a list of 5 data, -1, -5, 0, 5, 1, they are written that way. It is obvious that the mean is 0, right? Because the -5 and +5 cancel, the -1 and +1 cancel, leaving all zeros. So the mean of that's going to be 0. But typically, how big are the elements of the list? Well, I mean, they're typically somewhere between 1 and 5, and we could summarize that in a variety of different ways. If we use the RMS to do it, what do? We square each element of the list. We add those squares together, divide by how many there are. That gives us the mean of the squares, and then we take the square root of that to get the root of the mean of the squares. And it turns out to be 3.2 for that list. All right. Okay, what's the SD of a list? Well, we take the list of numbers and we turn it into a list of deviations from the mean. From each number in the list, we subtract the mean of the list. That gives the deviation of that element of the list from the mean. Okay? So then the standard deviation is the RMS of that list of deviations from the mean. So if we had a list of numbers like this, 630241, to find the standard deviation, first we'd find the mean of the list. We average the numbers in the list. That's 2.67. Then we make a new list, the list of deviations from the mean. So from the first element of the list, 6, we subtract the mean. From the second element of the list, we subtract the mean, etc. Okay? So what does that give us? It gives us this list of 6 numbers. First element minus the mean of the list gives us 3.33. Second element minus the mean gives us 0.33, etc. And now, from this list of deviations from the mean, we get the standard deviation by taking the RMS of this list. So what is that? We average the squares and take the square root. So we're going to square each of these things, divide by the number of things there are, add them together, add by how many there are. That's the mean of the squares, and then take the square root of that. So the standard deviation of this list is 1.97, plus or minus round off. Okay? So what is this telling us? It's giving us an idea of, on average, how far away is an element of the list from the mean of the list, where what far away means is the square of the difference. Okay, we're looking at the square root of the average squared distance from the mean. So if every number were equal to the mean, if all the numbers were equal, what would the standard deviation be? 0, right? Because all the numbers are equal to the mean. If all the numbers are equal, they are all equal to the mean, right? Because you add up a bunch of things that are all equal to each other and divide by how many there are, you get back what you started with. Yes? Okay. So if they're all equal to the mean. If you subtract each of them, if you subtract the mean from each of them, you get a list of zeros. If you square the zeros, you get 0. If you average the zeros, you get 0. And then if you take the square root, you get 0, right? So the standard deviation is going to be 0. Okay, if all the numbers are equal, the SD is 0. What happens to the interquartile range if all the numbers are equal? It's also 0, right? So if all the numbers are equal, then the lower quartile is that one value that they all take. The upper quartile is that one value that they all take, and the difference between those two numbers is 0. Yes? If all the numbers are equal, the range is 0 as well, right? If the interquartile range is 0, does it follow that all the numbers are equal? No, so that's a one-way entailment. If all the numbers are equal, the IQR is 0, but if the IQR is 0, then all the numbers don't have to be equal because it's not telling you what's happening with that lower 25% and upper 25% of the list, right? In fact, they could be arbitrarily different. If the range is 0, are all the numbers equal? Yeah, the largest minus the smallest is 0. That means they're all between the same number and the same number. What about the standard deviation? The standard deviation is 0. Are all the numbers equal? Yeah. Okay. Because when you square the deviations, you only get positive things. So when you add up a bunch of things that can't be negative, if you end up getting 0, then every single one of those things must be 0. So all of the deviations from the mean must be 0. Therefore, all of the numbers must be equal to the mean. Therefore, all the numbers are equal to each other.